starting on the study guide, we're on number 1. It says write the exponential equation as a logarithmic equation. And remember, to be able to do this the way that I've showed it, I say that logs are bay. And that just gives you the order to rewrite it in, because using some terminology that you already have, let me zoom in a little bit. Terminology you already have, you got that this is my base, this is my exponent, and this is my answer. So to rewrite this, I write logs are bay. So my base is 2. My a moves here in parentheses to my argument, and then e goes over here. Logs are bay. Moving to number 2. I'm going to move a little quick on these, and so you can pause and rewind if you need to as we go. This is the same thing. We're just rewriting it. There's 2 of each kind of question on this. So when I rewrite this one, logs are bay again. So my b is my base. This is my answer. On this one, the a becomes an argument here, but b, a, e. So -2 goes here. Bay. Okay. And then 3, we're going the other way. So number 3, we got write the logarithmic equation as an exponential equation. So remember, if it's a log form, logs are bay, B-A-E. And then we rewrite it, and my base is 5, my exponent is 3, and my answer is 125. It like goes to my base, exponent, answer. Yeah. Okay. So remember, when we're writing it in exponential form, we're writing it as an exponential equation. There's no log anymore. If it has a log still, then it's logarithmic form. Number 4. Now, one thing to remember, you'll see here there is no base. So if you see log by itself, it means log base 10. Same thing with ln. If you see ln, that means log base e. And a lot of this stuff, as we do this, a lot of this stuff that I'm writing out, like logs are bay, and writing out log is log base 10, this is perfect stuff to go on your index card later. So a good hint is, if I'm writing it out on the thing, it's probably something I put on the index card. So this is log base 10, so I can write out logs are bay, B-A-E. My base is 10, my exponent is -2, and then my answer is 1/100. Now, to be able to type this in our calculators, we have the sucky little TI-830s. So we're going to be working with rewriting this with base on bottom. So remember, so anytime we need to type it in for this class's purposes, we have to rewrite it with base on bottom. So that means the base becomes the bottom argument. So we're going to rewrite it with log over log. The 9 goes on bottom. 729 goes on top. So let me pull that up. It was 729 over 9, okay. So I just typed it in as a fraction, log 729 over log 9, that's 3. Okay. Same thing with this guy right here. I just rewrite it with base on bottom to be able to type it in. So I got log 36 over log 6. If I type it in my calculator, I should get 2. Number 7. We just did number 6, now we're on 7. So now we're going to this right here. We're going to rewrite it with base on bottom. Same thing again. So my argument goes on top. The base is 8, base on bottom. So let's type that in. Log. So remember, you got to go second, then this up, like the caret. So second caret, this will give you this. So 5, and then was it 8? Correct? Yep. For log of 8, which is 1/5. And usually, if yours gives you a decimal, remember you can go second table to switch it back and forth. So mine gave me a fraction. You want a fraction. If it gave you a decimal, you can go second table. So this is 1/5. And then same thing with this one. If it's ln, in our case, we can just type that directly in. We don't have to switch it. If it's ln, just type it in. So same thing here. I'm just going to type in ln's right below log right here. So ln, so second caret, 5, the fifth root of e to the 4th. So second ln, e to the 4th. Boom, 0.8, this is what I'm talking about. So if it gives you 0.8, which these calculators should, second table, we'll switch it to a fraction. Second table. That's probably a good one to write in the notes too. Index card. So this just gives you 4. So remember our condensing rules. These are definitely something that should go on here. So remember, let's just quickly write the short ones down. So add can go back and forth with multiply. Subtract, I can't spell. Can go back and forth with dividing, or put it on the bottom, or let's say denominator. Let's be fancy. And then the front can go back and forth with the exponent. And this is a definite definite index card kind of guy. So remember, when we're condensing, we're trying to get to 1 log. So condense means get 1 log. Like I want 1 log in the expression. First thing I got to do is move the front to the exponent. So I like to write it with parentheses too around my argument. You don't have to, but you suck and have no friends if you don't. I'm just kidding. You're all awesome. Unless you don't write with parentheses. And then addition becomes multiplication. So we multiply what's in parentheses. So y times b to the a is just going to be log of y times b to the a. Now number 10, same idea. We're going to move the fronts first. And then remember, with subtraction, if I've got the one with the subtraction sign, so we're talking about this guy right here. The one with the subtraction sign goes in the denominator when I divide. So this is going to be log of z to the d over k to the 6th. Same idea with 11. All we're doing is doing it with numbers instead, so it wants to rewrite with a single logarithm, so we're just condensing again. Addition, using our rules, becomes addition can condense with multiplication. So 3 times 6. And this can all happen because we have the same base. We got base b right here, right? So it's going to say log base b. 3 times 6 is 18. We follow the same order, even if it's just numbers. So the 3 moves to the exponent. So I've got 2 to the third right here. 2 to the third is the same thing as 8. So I've got log base b of 8 minus log base b of 2. Now let's write this step out, I guess. So remember, the one with the subtraction sign goes in the denominator. So log base b of 8 over 2, which is the same thing as log base b of 4. Now we're expanding. We're going the other direction. We're expanding. We're going the other direction. So one thing that would help you a lot here, 13. So expand fully. So remember, this is saying 4 times x to the 4th. It's not really written that way, but that's what we mean by 4x to the 4th. 4 times x to the 4th. And we want to expand it so we just have x by itself in parentheses, like as my argument. So remember, multiplication can go the other way. This multiplication can expand to addition. So that can be log 4 plus log of x to the 4th. And then we're basically doing the previous couple problems in reverse. And now this exponent can move to the front because we want log x. If we have log x, we want it by itself. So this log 4 didn't change. Log of 4 plus 4 log of x. Same thing here. This is x to the 4th times y. So then we can split this into addition. Log of x to the 4th plus log of y. And then this moves to the front. 4 log x plus log y. Yep. Since this is my answer because I've got it in terms of log x and log y. There's nothing in the exponent. And if we wanted to, it could be in either order because we can add it in either order. Now, to solve on number 15, if I'm solving with logs, you condense, switch forms with a you condense, switch forms with logs or bay, and then get x by itself. Then I get x by itself. So there's nothing in the front to move, so I just go straight. Well, this is addition, so addition becomes multiplication. So I'm going to multiply these two guys together. 2x times 2 is just going to give me log base 7 of 4x equals 5. And notice it says it wants an exact value of x. So if we get a decimal or fraction, a fraction's good.
And if it's a decimal, as long as it's a decimal, you don't have to round. But just let's do fractions. It's going to make life a lot easier. But we're not there quite yet. So now we need to rewrite this to be able to get x. We need to get rid of the log somehow to be able to get the x out of the parentheses. So let's rewrite with b. B, A, E. And then my base is 7, my exponent is 5, and then my answer is 4x. So I just rewrote that. My base, exponent, answer. So if I do this in my calculator, 7 to the 5th, 16,807. Equals 4x. And then just divide by 4 on both sides. And you could leave it as a decimal because this one terminates. It doesn't like go on forever. But I always prefer a fraction. You can see it's not even going to switch on your calculator because it's such a big number. Like this is my answer right here. Just 16,807 over 4. Or you could put the decimal, either one on this one. But I just don't want you to get in a bad habit of doing that. Okay. So let's look at this one. I'm doing the same thing I was for the previous one, except for I've got subtraction this time. And I've got a 3 in the front that I need to move first. So 3 to the front, that gives me 2 to the third here, right? I'm moving the 3 to the exponent. So 2 to the third is going to give me 8. So log base 2 of 6x minus log base 2 of 8 equals 0. I'm going to condense these with subtraction become a division. So I've got log base 2 of 6x over 8 equals 0. You can go ahead and simplify like what's in parentheses to 3x over 4 if you want to. It doesn't really matter. The math's going to work out the same. I'm going to choose not to, but totally your call on that one. So let's rewrite with B, A, E. So my base is 2, my exponent is 0, and my answer is 6x over 8. Okay. Remember, anything to the power of 0 is 1. Anything to the 0 power is 1. So this gives me 1 equals 6x over 8. So let's times 8 on both sides. So 8 equals 6x divided by 6. Now we just put this in as a fraction, 8 over 6. It's 4/3. So when I'm doing this, let's move on to the next one. But remember, there's going to be a Delta Math practice just like this for us to do. But for right now, you don't have to worry about it. But when you have the study guide, like I would have the study guide like pull it up so you can kind of check yourself, like how do I do this specific problem on the Delta Math? It'll be easy to see there. So let's go over to this one. So it's the same thing, solving for x with exponentials. You divide if needed. Oh, this is not going to fit well. I'll top it up, then I'll space it out. You divide if needed. Use base on bottom. Isolate x. This is like a. Here, I'll just let you write it if you need to here, okay? Put it right here.
So if you're solving for x with exponentials, like this is all the steps that you would do. You divide if you need to get it into the exponential form. Use bay if you need, like use bay to switch it to log form. Then to be able to type it in on our calculators, we need to write with base on bottom and then isolate x if it isn't already. Get x by itself. So this time we're already in base, exponent, and answer, like b, oh, sorry about that. We've got b, e, and a. I don't need to divide by anything. Sometimes there's something out front that I need to get rid of first, but not this time. So I can go ahead and skip to the second step. Let's go rewrite it. Logs are bay, so my base is e. BA, so then 2, then E is x. So remember, logs are bay. And there's a couple ways you could do this one. You could go straight to say log base E is ln, so you can do ln of 2. That's what a lot of people would prefer to do. But also, what we started to do in our, like, just using the same rule, base on bottom. You can do it either way. You can rewrite this as log of 2 over log of E. I'm okay with either one. Equals x, and x is by itself, so all I got to do is type this in my calculator. And I'll show you what I mean. If you just did ln of 2, it gives you 0.69. And then if you did log of 2 over log of E, remember you got to put e to the 1 because this calculator sucks. So regardless, we're rounded to the nearest hundredth, so it's 0.69. So this time, there is a number to divide in front. That's why I said you divide in front if needed. So we divide by 576 first, because we need to get into bay form. We need to get into, or BA form to get to bay. So remember, I like to type these as fractions. So 96 over 576 is 1/6. So I have 3 to the x is 1/6. Now I can rewrite that with bay, b, e, a. So logs are bay, logs base 3 of 1/6 equals x. X is by itself, so that's nice. So I just have to rewrite this with base on bottom, the change of base formula to be able to rewrite this. So log of 3 over log of 1/6 equals x. Log of 3, log of 1/6. Wait, did I do that backwards? I sure did. Oopsie. Sorry about that. Log of 3 is on bottom. Let me go ahead and do that. Log of 3 and log of 1/6. There we go. So negative 1.63. Okay. Now, 19 is similar, but a little bit different. You can't go ahead and multiply, like you can't go ahead and divide by 2. You got to get it out of the exponent first. So we go straight to bay. You only divide if it's out front. So right here, let's go ahead and just rewrite with bay. So b, e, a. So logs are bay. My base is 3. My a is 6, 7. And my e is 2x. Now, I go ahead and rewrite this. Yes, I'm laughing at 6, 7, 9, 28 and stuff. And we got log over log. My base is on bottom, so log 3. Log 67 on top equals 2x. So all I'm going to do is type this in my calculator, and then to get x by itself, I'm going to divide by 2. So I'm going to type it in my calculator first, the log over log, and then divide by 2. So log of 6.7 over log 3, and then divide that fella by 2. 1.91. Okay, and we got to, let's go ahead and do the next one. Same idea. This is kind of combining all the steps. So 98 divided by 98. 97 over 98 will not simplify. 3 to the 4x equals 97 over 98. So logs are B, B, E, A. So log base 3 of 97 over 98 equals 4x. So log base 3 I'm going to type that in and divide it by 4. So log of 97 over 98, yes. Log 3 divided by 4, which if you round that to the nearest hundredth is just going to be 0.